Okay, so we're going to do the Personal Finance Chapter 2 quiz review. So remember, we're going to use our steps that we've been using. So we're going to number the sentences. So this is 1. So a bike sells for a retail price of $150 from the online store. The wholesale price of the bike is $99. Find the markup. Find the percent increase in the markup to the nearest percent. So let's go ahead and number ours. So we have 1, 2, 3, 4 sentences. And we're going to circle so it says a retail price of $150. The wholesale price, the bike is $99. Find the markup. So we're solving for markup. Find the percent increase of the markup to the nearest percent. So that means to the nearest whole number. So we're going to round it to the ones place. So no decimals. Okay, so let's go ahead and do that. So remember, so for number 1, remember it's going to be wholesale plus the markup is equal to the resale. So we're going to go ahead and add those in. So it's going to be $99 plus the markup is equal to $150. We go and subtract $99 from each side. Remember what we do on the one side, we must do to the other side. So the markup is going to be equal to $51. Okay, and then we have to do find the percent increase. So that's for number 2. Remember, that's going to be the change. So I'm using delta for change over the original. Times 100 to get the percent. So we're going to go ahead and put that in. So the change is going to be the 150 minus the 99 divided by 99 because that was the original times 100. So I get that the percent increase is going to be 52%. Okay, Wanda's Widgets uses market surveys and linear regression to develop a demand function based on the wholesale price. A demand function for Wanda's Widgets is Q is equal to negative 140p plus 9,000 at a price of $50. How many widgets are demanded? So we're going to go ahead and use our strategy. So I go 1, 2, 3. I'm going to circle the key parts. A demand function. So this is demand function. Okay, at a price of $50, how many widgets are demanded? So what we're solving for is for Q. We want to know, remember, Q is the quantity. So we're going to go ahead and substitute in. So it's quantity is equal to negative 400. We're going to substitute in the 50. And that is going to be equal, so we get that one. So we substitute that in. Make sure you keep track of that negative sign. So we get 2,000. So $2,000 widgets are demanded when the price is $50. Okay, so this one's asking what's the fixed cost of the function. So the fixed cost, remember is going to be the second number, and it's the larger number. So that's going to be the 55,789. So that's the fixed. That's the fixed cost. And the variable cost is going to be the $4.14. So the variable cost is the $4.14. What's the average cost? So remember, average cost is going to be the expense divided by the quantity. So for 500 widgets, so our quantity is 500, round to the nearest cent, so that's 2 decimal places. So we're going to go ahead and substitute in. So we're going to have $4.14 times 500 plus 55,789. Remember, we have to do that first before we divide by the 500. So I'm going to get let me clean that up a little bit. Okay, so I get 57,895 divided by 500. So the average cost would be $11,572. And that would be for the average cost per widget. And I'm just going to double check that. You always want to double check your answers. So everybody, the way to do that is you can go ahead and substitute it back in and make sure that it makes sense. Like on this one, I should have written 5,9. So I'm just double checking my work. You always want to double check your work, everybody. And when I double checked my work, I found that it should have been 0.72. The answer that I got, everybody, remember, is $115. 0.7. Okay, remember 5 and up rounded up. So I look at this and I'm going to round this up to the nearest cent. So that's 2 decimal places. So this would be my final answer. So make sure you're putting in the decimal also. There's a huge difference between those two answers. Okay. So this one, okay, so we're going to use our strategy. It's a demand function for the makeup product. It's our first sentence. And what is the revenue is our second. What is the revenue if the price per makeup product is 25, demand function they give us. Okay, so our demand function. So we're going to substitute it in. It says hint, revenue is equal to the price times the demand function. So we're going to use that. So revenue is equal to, it's going to be the price of 25 times negative 300 times 25 plus 10,000 We're going to put that all in the calculator. So the revenue is going to be 62,000. $500. Remember, you can always double check it. Make sure you count your zeros, so you put all of it as 10,000 and double check your answer. Okay, so for this one, it says the demand function is, I feel like I went too fast. No. Okay, demand function. So this is our demand function. It's our first sentence. At a price of $30, how many jeans are demanded? So we are solving for Q. So we want to know how many we're going to have. So Q is going to be equal to negative 900 times 30 plus 120,000. We substitute that all in. Remember, it's going to be negative 900, so keep track of that negative sign. And make sure you have enough zeros. So I get 93,000. So 93,000 jeans are demanded when the price is $30. Okay, so this one is asking us to write the expense function. Okay, so I look right here, expense function is. Okay, so that's our second sentence. This is our first. So it has a fixed cost of 160,000. The labor materials cost is 150. Remember, demand expense function is equal to the variable cost times Q plus the fixed cost. Fixed is going to be the larger number, so expense function is going to be equal to 150 times the quantity plus 160,000. So that is our expense function. Okay, number 10, manufacturer and sells bowls for $15 wholesale. Recommended markup of $4.50. What's the recommended selling price? So that's what we're selling for. Recommended selling price is the same as retail. Okay, so this is in our first sentence, it gives us the wholesale and the markup. And in second sentence, it tells us what we're solving for, which is the retail. So remember from the first problem we did, it's wholesale plus the markup is equal to the retail or selling price. So we're just going to substitute that in. So 15 plus $4.45 is equal to $19.45. And that's our answer. Okay, so this one, I used Desmos, so I put in statistics, linear regression. So I just entered in all these points, okay, because it says find this following set of ordered pairs, or X and Y coordinates, give the results of the science experiment. 12 people are given different doses of vitamin C in milligrams for a year, okay. So it says, what is the regression equation? So remember, regression equation is going to be y is equal to the slope x plus b, which is the y-intercept. So if you look, it gives it to us right down here, okay, to the nearest thousandth. So that's 3 decimal places. So I'm going to go y is equal to it's going to be negative 0, 0, 2 x plus 3.215. Okay, remember 5 and up rounded up, so that's what I'm looking at for this. It says find the correlation coefficient. So our big correlation coefficient is R. So it's going to be that number. So it's R is equal to, it's going to be 0.7236. So that is our correlation coefficient. Okay, next one. So this one, again, I use Desmos. So let's find the equation of linear regression. So I'm going to use m is equal to mx plus b. Find the correlation coefficient, that is r. So that is right here. So r is equal to 0.746 because we were rounding to the hundredths place. Okay, and we're going to write the equation, so I'll write it down here. So y is going to be equal to 0.222x plus, and it's going to be negative 0.268. Okay, so that's coming from right there. And then it says describe the correlation. So it's going to be moderately strong. Remember with this, you want to look back at your notes for this. Okay, so remember the chart that we grew, the number line. Okay, so it's moderately strong. And the closer it gets to zero, the correlation gets weaker. Right there, it's weaker. The further it gets from zero, the correlation gets stronger. So that means the closer it gets to 1, it's going to get stronger.